So as I mentioned before, in finding the median, there is a special kind of case for which we find the median, which is using ordinal level data. And the reason for this is that there are some problems that can arise when using ordinal level data that don't happen if you're dealing with interval or ratio level data. So what I've written out on this new piece of paper is a new variable, and we're going to call this one officer education, and say that this is the highest level of education that 9 officers in our sample have. So this officer has a high school degree, this officer has an associate's degree, this officer has a bachelor's degree, and so on. So we have an N of 9, which is a total of 9 observations in our sample. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's say we want to find the median level of education for our 9 officers. Our first step, whichever way we're doing it, is going to be to list out these observations in order from least to most. So the least amount of education is going to be a high school degree, going all the way up to our greatest level of education, which is a master's. And we have 3 high school degrees here. We have 2 associate's degrees, 3 bachelor's degrees, and 1 master's degree. So there's our 9 degrees total, now listed in order from least to most, from high school to master's. You could find the median by counting inwards, but I'm going to run through one more example with the median position formula. So we're looking for our median position, and we know we can find this using the formula n plus 1 over 2. In this case, our n, or total number of observations, is equal to 9, so we'll plug that in. Plus 1 over 2, not 9 plus 2. So we have our median position formula here, which is 9 plus 1 over 2. If you add this up and divide it, you get a median position of 5. This means that your median is going to be in the 5th position as you count out here. So we're going to count 1, 2, 3, 4, 5 to find our median. We're in our 5th position here, in line in order from least to most. That's our median position. So this means that our median is going to be equal to an associate's degree. So in this data, we'd say that the median level of education for officers in our sample is an associate's degree. But wait, there's a potential problem that might occur. So let's imagine that we're going to add one more person to our sample who has a master's degree. So we're going to add one person. So I'm just going to add a master's degree onto the end here, but I'm going to write it out in a separate line. So we have high school, high school, high school, associates, associates, bachelors, 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 masters, and then we've got one more person who got their master's and is in our sample. So now we have an n of 10. We're going to find our median position formula, which is n plus 1 over 2. And in this case, it's going to be 10 plus 1 over 2. Add and divide that out, and you get a median position of 5.5. As in the last example, if you have a 0.5 in your median position, it means you're going to look at the number below it and the number above it. So here our median positions are going to be 5 and 6. So let's count out. We've got 1, 2, 3, 4, 5, 6. And our median position is somewhere in between an associate's and a bachelor's. As I said on the last page, when you have 2 different values for your median position, normally what you would do would be to add them together and divide by 2. So what's an associate's plus a bachelor's divided by 2? Nothing. It doesn't make any sense. So this is the downside to finding the median for ordinal data, which is that every once in a while you'll end up splitting a category, splitting your median between 2 categories, and because we can't do arithmetic with ordinal level variables, you're kind of stuck. So the best thing that you could do here would be to say that your median falls in between an associate's and a bachelor's degree.